Today we're going to be talking about function and function notation. So an example, if you look right here, we've got y is equal to x plus 5. Function notation is when you replace y with f of x. So it would read like the function of x right here is equal to x plus 5. So whatever variable is right there in this equation, that's the variable that will be inside that parenthesis. And if you look on over here, it says these mathematical statements all mean the same thing. So y equals 2x plus 3 is just an equation. A function, you can start with f of x equals 2x plus 3. You can even start with g of x. The thing is that this variable and that variable should be the same thing. H of a is equal to 2a plus 3. And that's pretty much it. So we're going to practice a little bit on converting equations into function notation. So just remember that whatever variable is listed here after the equal sign, that's a variable that will go there. And then all you have to do is copy x plus 2. Number 2, whatever variable is to the right of the equal sign, that's the variable that goes here. And then this whole expression right there, you just copy. So whatever variable is here to the right of the equal sign, that goes there, and then you just, that's right, copy. Whatever variable is here goes inside, and then guess what? You just copy. Whatever variable is there to the right of the equal sign, it goes there, and then copy t minus 10. And then whatever variable is here, you just copy. You just make sure that's the same one, and then you just copy. All right. What we're going to do now is work a little bit with completing some tables of values, and then we'll come back a little bit and show you how to integrate the function notation into the tables. So right here, if we have an equation, y equals 2x plus 1. You could also, since we're dealing with function notation, it may look like f of x is equal to 2x plus 1. So in place of y, you would actually have f of x. So that's something that you may see later on. But again, f of x is the same thing as y. So if we're going to complete this table, you have a given column of x values and you have an equation. So all you have to do is substitute -1 in place of x. So it would look like 2 times -1 plus 1. So that's -2 plus 1, which is -1. And then you have 2 times 0 plus 1. So that's 0 plus 1, which is 1. And then you have 2 times 1 is 2, plus 1 is 3, and then you have 2 times 3 is 6, plus 1 gives you 7. And so there we have just completed the table, given an equation. All right, now the input on number 7 were your x values. So all you had to do was substitute in. Now, something that's just a little bit different here is that your output is now given. So remember, your input represents your x and your output represents your y. So let's say we put a 12, our 12 right there went in place of y. So I'm just going to show it up here. So if we had 12 equals x plus 10, and we were going to solve that, what we would do if we were going to solve for x, we would subtract 10 from both sides. So x is equal to 2. So if we put a 2 here, 2 plus 10 gives us the 12. So basically, as a shortcut, what we can do with each one of these output values, just like we did up here, is we subtract 10 from each one of these values. So 8 minus 10, same sign, add and keep, different sign, subtract. Take the sign of the higher, then you'll be exact. So the 10 is the higher number, and it has a minus sign in front of it. All right, then we have negative 20 minus 10. Now, these are same signs. Same sign, add and keep the negative. And then 0 minus 10 is negative 10. So those are two different ways of filling in a table. One when the input or the x value is given, and one where the output or the y value is given. All right, so then we're going to go into domain and range. So the domain values represent the input, the x-axis or x values, and the independent variable. The range represents the output, the y-axis or y values, and the dependent variable. So we call this Dixie-Royd. So it says, given the set of points, what are the range values? So you can see I kind of give it away right there by saying range and then y. And that vertical line means such as, when y is equal to. So you list these y values. So when you're listing the domain and range, it's good to list these in numerical order. You don't have to list them according to how they appear with the ordered pair. So I would list 8, 9, 15. On number 10, it says, given the set of points, what is the domain? Domain is the x. So that would be all of the x values. But if you notice, they all repeat. So anytime the domain or range repeats, you only need to list it one time. Going on to problem 11, says for the following function, find the range values from the given domain values. So this is where you would take half of negative 4, so half of negative 4 plus 3. So a positive times a negative is going to give a negative. So whatever we get here will be a negative. So half of 4 is 2, but it's a negative. So negative 2 plus 3. So this is going to be negative 2 plus 3. So negative 2 plus 3, same signs, add and keep, different signs, subtract. So 3 minus 2 is 1. Take the sign of the higher, then you'll be exact. So it's a positive 1, stays a positive 1. So half of negative 2 would be negative 1 plus 3. So basically this is 3 minus 1, which is 2. And then half of 0, well, anything times 0 is just 0. So you'll have 0 plus 3, so that'll be 3. And then you'll have half of 2 is 1, and 1 plus 3 gives you 4. Okay? And I know that it said the workspace, but I was able to put the work right here next to the problem. But if you need bigger space, here is some space all over here that you can work on. So now I'm going to list my range values, which would be 1, 2, 3, 4. They're already kind of in least to greatest order. All right, let's look at number 12. For the following function, find the domain values from the given range. So this one may take a little bit more space. So I'm going to come over here. And remember, f of x is the same thing as y. So if you have, we're just going to come over here. So let's say instead of f of x, we have y equals 5x. Or we can just leave it as f of x equals 5x. So that would help out in the table. So if we have a negative 30, that's our first y value, or f of x. So negative 30 equals 5 times x. So if we were going to solve this one for x, we would need to divide both sides by 5. So x equals negative 6. So negative 6 will go here. So basically what we need to do with this y value is divide them by 5. So on every single one of these, we're going to just divide by 5. So negative 20 divided by 5 is negative 4. 10 divided by 5 is 2. And 15 divided by 5 is 3. So now when we list these are already in order. So we're going to do negative 6, negative 4, 2, and 3 would be how we list our domain values.